Miroslav Jeras. He is an expert on NMOS IS-07, which is a very essential part of the NMOS suite, allowing you to individually control specific contacts and actions and things like that. All the good stuff we need to actually make a live production work. So take it away, Miroslav.
Thank you, Wes. And welcome to the IP Showcase. So we are going to look at the IS-07 specification. First, a bit of what it is, how does it work, and then we are also going to have a look at a couple of use cases for from the first real-life project that implements IS-07. So let's start just with a couple of general information. So IS-07 is one of the EMVA interface specifications, like ISO 4, 5, 6, 8, 9. Full name, AMA ISO-07 NMOS event and tally. And that's a protocol that allows a source to publish its state and also to communicate all the state changes to the receivers that are subscribed. Now, this is sort of a formal definition, but we will have a look what it actually means. As the other specifications, it is published on GitHub. There is the code on GitHub and also the GitHub pages where you can find the documentation in a nicely rendered HTML format. So where did it start from? So every broadcast facility, I think, in the past would have some GPI signals. And in a traditional, let's say, SDI world or even analog world before that, those would be electrical signals that are carried over physical cables. So it's just an on-off signal. And obviously, that doesn't work well in the modern IP environments. I mean, you could have, let's say, a private cloud implementation and run some cables to do GPIs, but wouldn't make much sense. But even then, if you go to virtualized platforms, you know, like public cloud, well, you are not going to run cables in Amazon. That's for sure. And we needed to come up with an equivalent that would be an open standard and which would hopefully get a lot of traction. And so the vendors would support it, and you would be able to connect them easily. So looking at those requirements, we started with simple GPI and looked at how it translates into the modern IT world. So there it was on-off in terms of the electrical signals, so it's now true-false in terms of some Boolean variables. And while it was carried over some dedicated cables previously, it is now carried over the IP network. And when you do something like that, you need to have a format of the messages. And JSON was selected as the message format for the standard. Now, one of the common questions that I get asked is, oh, but you know, with GPIs, with physical ones, you know, when a voltage appears on the source, it will be at the receiver almost instantaneously. With networks, you could have unpredictable delays. So what about timing? So I would say that IS-07 is even better in terms of precision and frame accuracy than the regular GPI, because it is based on the PTP timings, SMPTE 2059, which is the same timing mechanism used for all the RTP streams. So you can have timestamps into those messages targeting specific frames or even audio samples. So it could very easily be sample accurate. Also, it supports multiple types of timestamps, like creation timestamps, origin timestamps, activation timestamps, which help keep track of the propagation of the message through the chain. And finally, the activation one would target the exact frame when this message should be applied. Of course, for most applications, frame accuracy isn't important, but if it's important, there is the facility to get it very, very accurate. So we started with GPIs, but we now have a very nice JSON message, and JSON is capable of carrying other data types. So strings and numbers were added to be carried into that. So we now can transmit more more information. But then another problem is if we are talking about numbers, so you receive on your receiver number 5. And what is it? You know, just a number doesn't mean that much. So we added also type definition, which can, let's say, which can bring a unit of measure into that. So it says, okay, that is 5 degrees Celsius, or 5 megabits. Also, the type definition can help define expected values. So you can define that you are expecting values 1, 2, 3, and 4, and 1 means this, 2 means that, and so on. And also, for the numeric variables, you could also have ranges. So let's say the receiver is a control system UI, which has a nice interface that can show a thermometer, for example. If you say that your range is -20 to 100, then that receiver would immediately be able to scale itself. And that type definition is carried also using the same methods, although it is not sent with each message again, just to make it more efficient. So it is available as a type definition on the source. Now, a very brief example how all this looks like. So this is an, let's say, average message. There is the identity part, which defines the source and the flow IDs for the message. There is the event type, timing information. In this case, we just have the creation timestamp, which is when the message was created. And there is the payload. In this case, it is a string saying OK. So this would be probably a status signal from a device saying that everything's fine. And there's the message type just saying that this is a state message to differentiate from some other auxiliary messages. And then let's have a look at this type definition that goes with this. So in this case, it is a value list defined on top of the string type. So we can have, if you see in the array, we have an array of 4 elements, and the value could be unknown, OK, warn, or fail. So that will be the actual payload that will be transmitted in the messages, as we have the OK here. But then, to go with those values, there are labels and more verbose descriptions, which are optional, but they could then help the, let's say, the control system or the receiving device put some more sense to the word OK. Now, if we are talking about strings, it's maybe not as required as if we were talking about numbers, because we could also be saying 0, 1, 2, 3, and then attach labels to those numbers. So the next question is, we now defined the message format, we defined the timings, types, and so on, but they need to be carried across the network. So we had our cables, and in the IP world, it is a bit more difficult as you have a couple of layers of transport. So those JSONs had to be carried over a transport mechanism. So there are 2 mechanisms that are supported here, and one is MQTT, which is a very common Internet of Things protocol. It is based on a broker, so it is centralized, so all the messages go to one location and are distributed by means of subscriptions to any listener that could be interested. And this is a solution that is very scalable. Those servers can easily handle hundreds and thousands of nodes, if not more. However, it covers some of the use cases, but not all of them. So also, IS-07 supports WebSockets, which is not a new technology. This is a protocol that is already used in ISO4, sorry. And one of its advantages, or disadvantages, depending on the use case, is that it doesn't require a broker. And in this case, we have one-to-one connections between the nodes, and by that, we have a simpler setup. And also, in case when speed is important, we get probably optimal speed because it is point-to-point. It's not going into a broker, into a queue, and then back. So it should be at least twice as fast as MQTT, in case that is important. Now, this is not an isolated standard. It sits on top of the other standards. So it uses the NMOS object model. So you would find the same sources, flows, senders, receivers, as you would find in other specifications, like ISO 4 or 5. All the ISO-07 resources are members and or children of devices and nodes, so everything, the entire model is followed. Everything is registered in the registry, and ISO-5 is used for connection management, which is quite an important property of the standard, as we will see later and in the demo that we have in the room. And also, the newest work in EMVA, BCP 00301, to define the security, is applicable on ISO-7. So all the ISO-7 transports can work on secure transports. So secure HTTP, HTTPS, WebSocket secure, and also secure connections to the MQTT broker. But also, those signals, if applicable, can be linked to audio-video very easily using the natural grouping. So as you will see in some of the later use cases and in the demo, you can easily, for example, attach a channel name or some automation metadata like counters, current events, and so on, to the audio and video groups, as you would mark them in like channel 1 video, channel 1 audio. You could have channel 1 channel name, channel 1 counter to the next event, channel 1 next event, and so on. So that's all groups, so the control system can easily match those counters to actual video signals that are coming out of your system. And now, those were the basics of the protocol, but let's have a look at how it can be used. So the first big real-life project using ISO-7 is the Metechno project in Zurich. So TPC is the playout service provider, I think, for the main German Swiss radio and television channels. And one of the main requirements for the new building was that open standards are used. And NMOS ISO 4 and 5 covered most of the signal management requirements for the video, audio, and the metadata flows. But there were a number of, I would call them, system integrations requirements that were not covered by any existing standards at that time. And that is when ISO 7 was suggested as one method that could solve those problems in an open standard way. So let's have a look at those use cases. So we basically have 5, I would say, almost completely different use cases, all of them solved by ISO 7. So the first one is the obvious one. There was a need for GPI triggers to control a downstream device. But also the requirement was that based on which machine is playing the channel, is it the main machine, backup machine, or even the emergency backup, that signal should have been routed from the correct machine. So the solution to that is to implement a Boolean ISO 7 sender, sending logical true-false messages instead of a traditional device that would be just sending electrical signals. And then, based on the input from the channel management logic, the control system can then route those signals to pick the one from the main machine. So basically, it receives an ISO 7 again signal telling the name of the machine, and then based on a predefined table, it makes the subscription to one or the other or the third one sender of the metadata. The second requirement was the ability to select a preview location within the playout server, and also when doing preview to select audio shuffle, because TPC operates in a way that they have surround and stereo sound, and that is in original language and in German. So the solution for this one was to expose the automation panel buttons that can do those things as Boolean receivers. So in a way, the control system is able to press the buttons on the automation smart panel. And in that case, if an operator wants to do the same thing, he can do that in the local user interface, but also the automation could do it for him if the control is from somewhere else. And in terms of redundancy, It just means that main and backup system have to listen to the same source, and they will all follow the same commands if required. Obviously, one good thing is that this is a very generic way of control, and it's very easy to add additional functionality on top of this mechanism. The third use case was what I called automation statistics output. So the channels that are being played out there have those properties like channel name, current event, countdown to next event, and also, most importantly, countdown to next live event. And the customer needed to be able to route those signals in the studio. So in the studio, they would see when the live event is coming up. The solution to this is a series of string senders for all the automation statistics that might be needed, that send the time code and just a plus-minus sign to know the direction. So if they go into overrun, they would be able to indicate that by showing the time code, for example, in red. And in terms of redundancy, again, the same pattern as for GPIs, as the routing is done based on the machine running the channel. A bit of future work would probably be to introduce another format, a more complex format, but also to standardize it for timecode, so it's not sent by string, in which case we would be able to add things like frame rates, and probably have the direction done in a nicer way. But that's for the second phase of development. Now, another, I think it is fourth use case, was to synchronize the user interface and the monitoring equipment, the multiviewers on the walls, as the requirement was to automatically reconfigure the monitoring based on the channel that the operator is viewing and operating. Now, the solution for that was to expose the name of the layout, and the name of the layout in the automation system would be like channel 1, channel 2, channel 3. And then, in this case, as the multiviewer is not IS-07 enabled, the control system picks that up and does the reconfiguration of the multiviewer in a, let's say, traditional way over some proprietary protocols, whatever is used by the multiviewer. Of course, in the future, the multiviewer itself could be IS-07, but also IS-05 compatible. And in that case, it would be actually very seamless, as you would be able to configure that in a very generic way. And this is something that you can also see in the future zone demo at the other end of the room. And the last use case for IS-07 at TPC was network port status logging, telemetry, as a couple of various systems running on the network should be reporting their port statuses, like errors, data rates, IP addresses, to other interested parties, logging system, network controller, broadcast controller, whoever would like to listen. So the solution to this is sending a couplet object, which means that the payload is now not a string number or boolean, but another object, another JSON, if you like, that can then contain all the elementary types. And then a range of information, it could be hundreds of pieces of information, could be sent over a single connection. And then all the devices that are interested in that information could easily subscribe to that and pick what they need. Of course, the type definition in that case lists the fields that are involved, something like a MIB for SNMP. So, given how we were able to resolve 5 different cases, we call it like a Swiss Army knife for system integration, as it was like a universal tool to solve completely different requirements. As I mentioned before, we have a very nice demo on the other end of the room, which consists of a hardware button panel, a software button panel, playout automation, a multi-viewer, a signal probe, control system, and an NMOS registry. And the data types that are used there are Boolean for button presses, numbers for various enumerations or colors, and also strings for various text fields, time codes. Even an image is encoded as a string over there. And after this presentation, I would invite you to join me over there, and I can give you a demo of the functionality and show some of those things in how they work in practice. Now, what is next for IS-07? As we now have all the transport mechanisms, we have the message formats, but what is missing maybe at the moment is to figure out what is expected from certain types of devices. So, for example, what properties should a button expose, how it should behave, what properties should multiviewer support on their inputs, what would be the essential fields for telemetry. So we hope that based on the experience of this project and other projects, we will be able to start building best practices or recommendations as to what needs to be included in each type of device to ensure interoperability, to avoid situations that one vendor calls it a bit rate and another one calls it the data rate, and then they cannot talk, or one sends megabits, the other expects gigabytes or whatever. The other area where we can have improvements is better standardization of the complex objects in terms of defining how the type definition is working and potentially adding some validation, and perhaps even allowing incremental updates for large objects, so we would optimize the number of pieces of data transmitted. And then we need more use cases and real-life projects to build the specification, especially in terms of best practices. So that's it for the presentation part, and as I said, welcome you to, well, you're welcome to join the demo after this. And if you have any questions, please let me know.
Thanks, Miroslav. So any questions from the audience? Yeah, hold on.
Yeah, Chris from Atos BNCS. So Miroslav, do you have any project examples that you are aware of, or where projects are now able to use these and adoption from wider manufacturers? Obviously, you have the use cases you've explained this morning. Are you seeing wider adoption?
Well, in terms of project, unfortunately not at this time, but in terms of the number of companies implementing it and showing interest in implementing, yes. So I think, yeah, we are probably not in a position where we have the critical mass for wide adoption, but we are getting there. I wish it would be quicker, but it's happening, especially at this IBC. There were a couple of very good meetings with people who are interested in doing that, both on the vendors and the system integrator side.
Okay, any other questions? All right, thank you very much. And we'll get set up for the next presentation.